Today's lesson, we're going to look at how to separate mixtures. Now, firstly, we need to consider the difference between a pure substance and an impure substance. So a pure substance is made up of just one type of element or compound. And obviously an impure substance will contain more than one. For example, orange juice would contain oranges and water in it, so it will not be pure. Now, the way you can spot a pure substance is it will have a fixed melting point, which means a very small melting point range. So it's very sharp. Whereas if you have a mixture, you're going to have a much wider range. That's the general rule that you have to know on your syllabus. So if you're pure, you have a fixed melting point or a very small range. If you're a mixture, you have a wide melting point range. If you add an impurity to something, it will lower the melting point and it will raise the boiling point. The greater the impurity, the bigger the range. So that will determine how pure something is. So if you think about adding salt to water and then trying to boil it, that will actually have a boiling point higher than 100. It'll be 101, 102. That's why, for example, if you're cooking pasta, you're advised to boil the water first before you add the salt. Now, freezing points, which is not on the notes, freezing points are lowered by impurities. So if you think about putting salt on the roads in the winter, that's done to lower the freezing point of water, so the roads don't get as icy as quickly. And as it says here, impurities will lower melting points. This is just a piece of apparatus you can use to measure melting point. You don't need to worry about this. Now, to separate a mixture, we just need a very quick reminder of the difference between element mixtures and compounds. So a compound will have two different elements bonded together chemically. A mixture will have different substances not chemically bonded. Hence, it can be separated by physical means. If you compare compounds and mixtures, mixtures have no fixed ratios, whereas compounds will be something like H2O. So they will have a fixed ratio. To separate a compound, you'll need to break chemical bonds between atoms, and therefore you'll need a chemical method, such as electrolysis, which is one of our future topics. Now, for mixtures, you can use physical methods, so based off of its melting or boiling point and other properties. The main methods that you need to worry about in your specification are as follows: filtration, crystallization, distillation in terms of simple distillation and fractional distillation, and chromatography. We've been over the S words before in the previous lessons. Let's start with filtration. Filtration can be used to separate an insoluble substance from something soluble. So for example, sand does not dissolve in water. So if you have sand and water mixed together, you can simply pour your mixture into a filter funnel with a filter paper and collect the solid as a residue in the filter paper. So this is called a residue, and this is called the filtrate. The filtrate is the stuff that goes through, because the particles are small enough to pass through the filter paper, whereas the insoluble substance particles are too big to pass through the filter paper. You should always remember that you have to wash your filtrate with distilled water to remove any solution that's left on it. That will remove any impurities, and then you will have to leave it to dry if you want a pure dry substance. So remember, this is how to separate an insoluble solid. Now, crystallization is used to remove the solution and be left with the solid if the solid is soluble. So in this one, the solid was insoluble. In this one, the solid is soluble. So if you have a soluble salt, what you do is you pour it into an evaporating basin and you heat it. You can either heat it directly on a gauze, or you can heat it more gently using a water bath. The water bath heats up, the water evaporates, and therefore in turn heats up the evaporating basin. The particles gain energy and break the force of attraction between them and escape. Heating should be stopped when usually approximately half the water is boiled off, or in other words, when crystals start to form on the edge. You can actually dip a glass rod in it and take it out and see if crystals are starting to form. That means you reach the crystallization point. You then remove the evaporating basin and let the rest of the water evaporate slowly at room temperature. That allows you to form big crystals. So you actually, after you take it out of the evaporating basin, you leave it to cool slowly to get big crystals, and then you let it by the windowsill by the sun for the water to evaporate. If you want it to be quicker, you can just filter it, but then you'll lose some of your product because not all the crystals have come out. You can use a flat bottom dish for this final stage because it provides a larger surface area for your water to evaporate from. The next two methods will be simple distillation and fractional distillation. So simple distillation is when you have the same scenario as above, a soluble salt. However, you're not looking to collect the salt, you're looking to collect the liquid. So a soluble salt can be obtained in here, or the solvent can be obtained in here. So this process, simple distillation, refers to a solid in a solvent. You heat your solution and you boil. So this is salt water, the solid being the salt. You boil the water, it rises up, and it goes into this Liebig condenser. This is called a Liebig condenser. As it goes into the Liebig condenser, it cools down because cold water is flowing on the outside of the condenser. And as it cools, it condenses and goes in here as a distillate. This is the pure solvent, in this case, the pure water. The salt will be left behind. The important points on this is that the water enters the Liebig condenser from the bottom and goes up from the top against gravity. That is done in order to ensure the condenser is full of water for efficient condensation. Because if you're going against gravity, the water will go in quicker and it'll go out slower. Whereas if you go with gravity, the other way around, the water will go in as fast as it goes out, so the condenser will be half full of water. Other important points is the thermometer should be at this T-junction here, so it can measure the temperature accurately of the vapors. Any dissolved solids will remain in the flask. The next one is fractional distillation. Now, fractional distillation is for miscible liquids that dissolve in each other. So the previous one was a solid inside a liquid, such as, for example, ink is the solid and water is the solvent, or the salt and water example. This is when you have two or more miscible liquids with different boiling points. They must have different boiling points. So you can have ethanol and water, you can have ethanol, water, and butanol, you can have multiple liquids which mix and dissolve. So the difference here is that you have this extra thing called a fractionating column that was not present before in the previous equipment. The fractionating column is made of these glass beads. Okay, the beads ensure increase the surface area. So what happens is, once again, you boil, you heat up your solution. These anti-bumping granules are used to prevent large bubbles. Now, as you heat this, the one with the lower boiling point will come off first. So the beads in the column ensure that the liquid with a higher boiling point condenses more readily on the cooler beads near the bottom and drips back. So as the evaporation happens, the lower boiling point liquid will continue to pass through the condenser into here and then cool and condense. Whereas the one with a higher boiling point, even if it does evaporate a little bit, it will stop here and drip back in. So that ensures the thermometer will, for example, stay at 78 degrees until all the ethanol is boiled off. Then once all the ethanol is gone, the temperature will continue to rise for the next liquid to come off. In this case, water is 100. So as soon as your ethanol comes off, you're pretty much done, because then your water will be left behind. So what you collect here is called a fraction. So if you have more than one liquid, if you have more than two liquids, the first fraction would be ethanol, then the next fraction, say, would be water, And then the next fraction might be another liquid that has an even higher boiling point than water. So you collect it in fractions. The important point is the liquid with a lower boiling point is the one that condenses first. And that's fractional distillation. This will be covered again when you do organic chemistry, and we look at crude oil being separated. A small note, there's something called a separating funnel, which is for immiscible liquids. So this was miscible liquids, which mix with each other. Immiscible liquids don't mix with each other. Example, oil and water, or oil and vinegar. So what happens is you put them into a separating funnel, you close it, you close the tap, and you shake it. Then what happens is you'll get two layers. The more dense one will be on the bottom, and the less dense one will be on the top. You can then open the tap and collect the bottom layer, close the tap, and the top layer will also be left behind. So you would have separated your two liquids. You could even do this for 3 liquids, because then there'll be 3 layers. The key point is they must have different densities. Now, the final bit we need to go over is chromatography. So paper chromatography. This will be done in the next lesson. So this is the end of this part. The chromatography is a little bit of a bigger topic, so we will do it in a separate lesson. See you next time.